To another exciting day in mathematics. Whoop, whoop. Warm up 125 is on the screen. Let's get started, please. Pretty much it's the same problems as before. I took out the transformations and I added the unit circle so that we can start practicing that. So I'll give you guys some time. Ready, go. Hands if you need more time for that warm up. All right, I'll give you a little bit more time. Let's get this show on the road. Warm up 125. Here we go. By now, these should be automatic. You should have gotten 1 over 81 for 1A. Hands if you got that. Okay, good. 1B, you should have gotten 64 or 64 over 1. For 1C, you should have gotten square root of 27. Square root of 27. Number 2, you should have gotten 2 to the x over 32. Number 3, I'm just going to go through this one more time to make sure we got it. 125 to the 1/3 power times 2 power. 1/3 power is a cube root of 125. Then you bring the power of 2 down. So the question is, what number times itself 3 times give us 125? That number is 5. Bring down the power of 2. So 5 squared is 25. Number 4, sine of angle A, opposite over hypotenuse. So angle A is right here. What side is opposite to angle A? That side is 5 over, which is the longest side of the triangle? 13. So that's 5 over 13. Cosine angle A. Cosine is adjacent over hypotenuse. Which angle is next to, what side is next to angle A? The side is 12 over 13. Tangent angle A. Tangent angle A is opposite over adjacent. What side was opposite? 5. Which one's adjacent? 12. So it's 5 over 12. And if you notice on the study guide, this is problem number 32 on the study guide. Last problem of the final. Let's go to the unit circle. It said copy the circle. Now let me make a quick observation. Look up. From the video lessons that I left you guys for this, check this out. If you memorize these 3 points on the unit circle, you can fill out the whole unit circle 1 quadrant at a time. Check this out. This one is square root 3 over 2, comma 1/2. This point right here, square root 2 over 2, comma square root 2 over 2. And this one is 1/2 square root 3 over 2. Now check this out. If this is quadrant 1, we know that the x and the y values are both what? Positive, is that correct? That means if I go to quadrant 2, the x becomes what? Negative, and the y still is positive. So basically, just take these points, reflect them over here, look at this one, and then just change the x value to a negative. Same thing with this one. Reflect it over here, the x value negative. Reflect that over here, the x value negative. So far so good, yeah? To fill in the 3rd quadrant, what do we know about the 3rd quadrant? That the x and the y, both of them are what? Negative. So from here we do this. Bring this one, reflect it here, put both negative, both negative, both negative. And last but not least, for quadrant 4, reflect that over here. The x is positive, the y is negative. X positive, y negative. X positive, Y negative, X positive, Y negative. And that's how you fill your unit circle. We good? All right. So, with that said, copy the agenda, please. Warm-up 125 done. We're in the middle of log functions. Tonight's home play sheet 16.1, numbers 1 through 12, all only. Today we're moving on to properties. So make sure you're keeping up with your practice, please. And by the way, from the warm-up, the unit circle, if you notice on your study guide, that's problem number 31 on the study guide. Second to last problem. All right, we good? All right, copy the code to access the home plate. GT4V8. 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 All right. So, with that said, last night's home play, I hope you did well with that. Let's see. There might have been some questions on the last three, which is fine. Let me go over one of them just for the sake of going over some of these. Zoom in. It says, write the given exponential equation as a log. So, let's see. What is my exponent here on this one? It's a 3. So we start with 3 equals log. What is the base? The base was 5 given 125. That's how you do those. You always start with the exponents. Same thing with here, here, all of those. These, change those to exponential. So, we start with what? With the base. What is the base on that one? 6. What is the exponent? 4. And what is the given number? 1296. And so on and so forth. You use this to start filling these in there. I'm going to do, which one? You want me to do this one right here? All right, so f of square root of 27 equals log 3 square root of 27. So the first step that we did yesterday, we changed that to y. Log 3 square root 27. Change it to exponential. What is my base? 3 to the y equals square root of 27. Are we doing so far? Yes? All right. So we need this side to look like this. So 3 to the y equals, first of all, look up, guys. How can I write 27 in base 3? 3 times how many times by itself? To the third, yeah? So it's 3 to the third. However, what happened to the square root? What is the square root in exponential form? From the warm-up, what did we do with the square roots? What was square root of, what was it in fraction form? Elijah? 1/2, that is correct. The square root becomes a half. 27 is 3 to the third. So 3y equals 3 times 1/2 is 3 halves. Therefore, y equals 3 over 2. And for the other two, remember the last one is the one that's going to give you a little bit more of a challenge because you need to use half or 1/3 powers and so on and so forth. All right. All right, set that aside. Oh, this is tonight's home play. Let's go, Mario. All right, get a Cornell note ready, please. I can simplify log functions. I can simplify log functions. Ready? Here we go. I can simplify log functions. I can simplify log functions. So by now we know what log functions are. We did our Fourier model. I gave you guys these notes. You have them already. But remind your neighbor what it specifically makes these log functions and not these. What makes them a log function? Caesar, what makes them a log function? The word log, that is correct. All right, from there we did log to exponential and exponential to log. We did some of those. And on your paper, copy this, please. Log b to the n. And underneath, you're going to draw a line like this. Leave some space here because we're going to do stuff here. And then example Q, log 3 to the 4th. Then you draw a line down. Then you're going to write log b of b. Underneath the line, log 2 of 2. And on the right side, log b of 1. And underneath, log 10 of 1. I'll give you some time. All right. So in logs, guys, there's certain rules that are obvious rules, which are the ones in front of you that we're going to go over. What does that mean, obvious, Mr. Q? Let me look up, please. It's kind of like this. I've been hammering so far that any number to the 0 exponent, the answer is always what, everyone? 1. That is correct. That's a rule that you should know by now. The other obvious one is that a number to the exponent of 1 is that number itself. Those are 2 rules that you should know by now. So in logs, there's 3 rules that you should know. The first one is that, here it goes, that if you have a log to a certain base and the number given has the same base and an exponent, the answer to this is y equals m. Don't write that down yet. I'm just showing you that that's a given to know. Now, how do we conclude that, Mr. Q? Let me show you. Look up. We set this equal to y. Now that we have a log function, the first thing we do is change it to what? Exponential, is that correct? So, what is my base? Base is b. My exponent is y. And what is the given number? b to the m. Is that correct? And what do we know? Since these are the same, we just focus on the exponent. So what does that say? Y equals to what? M. Copy that, please. And once again, these are given rules that you should remember once we get into more log properties. So we did that with variables. So the first thing you look at is if you have a log with a base and the base is the same as the number given and the number given has an exponent, the answer is the exponent. So look at this one. Look up. Log 3 to the 4th. Set it equal to y. What is y? Tell your neighbor. What is y equal to? Y equals to what, Rebecca? Help her out, Renzo. Y equals what? 4. That is correct. How did we know that? Well, let's see. I said, if the basis of the given number and the base of the log are the same, the answer is the exponent on the given number. So let's see, are these the same? Yes. So what is the answer? The exponent on the given number. Y equals 4. Do I need to do all this? No. All right. Let's go to the next one. Y'all ready? If you have a log where the base is the same as the given number and the given number doesn't have an exponent, the answer is y equals 1. Y equals 1. How do you conclude that, Mr. Q? Let's prove it. Set it equal to y. Let's write it as exponential. So my base is b to the y equals to the given number b. So are these the same base? Yes. What is the invisible exponent here, guys? An invisible 1. That's why the answer is y equals 1. Therefore, look at this one. And once again, this has to be equal to that. So is this equal to this? Yes? So tell your neighbor what y is equal to this one. What is y equal to? Enrique, y equals to what? Close. 1. That is correct. Yeah, because the exponent on the 2 is an invisible number, yes? All right. How we doing? Not bad? Last one. Here it goes. Whenever you have a log with a certain base and the given number is 1, the answer is always 0. All right, let's prove it. Set this equal to y. Change it to exponential. So we got b to the y equals 1. You're like, wait a minute, Mr. Q. It's a 1 instead of a b. All right, so let's change that. They need to be the same base. So question, what exponent should be on the b in order for this side to be equal to 1? What did we just say? Any number to the what exponent? To the what exponent, Mario? 0. Very good. 0. B to the 0 is 1. So that's why y equal to 0. So, look at this one. Log base 10, but the given number is 1, so what is y, everyone? Y is equal to 0. That is correct. All right, so remember these, because these are the given ones that we're going to be looking at. All right, here we go. With that said, today we're going to be covering product property of logarithms and quotient property of logarithms. So write this down in your notes. Product property of logs. What does it say? Well, it says this. When you have a log or two logs of the same base and they are being added, you make them into one log and you multiply the given numbers. Let's see if you see it. Is this log the same base as this one? Yes, they're both these. And what are they doing? They're being added. Okay. Therefore, if they're being added, we make them into one log of the same base. And what do we do with the given numbers? The given numbers for each log, we multiply them. M times N. Or if we reverse it, if they give us a log with a base and two numbers multiplying, we can split them up by making them their own log of the same base, each number, and then we do the sum. All right? So, put that into practice. Here we go. Copy this one. Example 1. It says, express each expression as a single log. Simplify if possible. Log 2, 8 plus log 2, 16. Write that down, please. Log 2, 8, log 2, 16. All right, good talk. So here it goes. First thing we check, do they have the same base? Yes, Mr. Q, they have the same base. Are they being added? Yes. So that means we write them both in only one log. Here's the one log right here. Same base. And what do we do with the given numbers? The given numbers, we multiply them. So log 2, 8 times 16, there it is. That's 144, and done. Let me send you the screen. A code so you can send me your notes, please. All right. So yeah, let's rewrite this because I did that on purpose to see if you guys were paying attention. So 8 times 6 is 48. We got 4. 8 plus 4 is 12, so that's 128. Thank you, Caitlin, Ashlyn. All right. Nice. All right. So, we good on the process? Yes. Just forgive my computation. I did that on purpose to see if you guys were focused. All right, let's go to the next one. Copy this one. Example 1Q, log 3, 3 plus log 381. Log 3 of 3 plus log 381. All right, let's do this one together. Here goes the process. What's the first thing we check, Geo? Make sure the logs have the same what? Same base, same base. Do they have the same base, people? Yes. What is the second thing? Are they being added? Yes. So if those two are there, then we write log base 3 only once. All right. And what do we do with the given numbers for each? The given number is 3 over here. This 181. We write them as 3 times 81. Let's simplify. So log 3. 3 times 81, that is 3 times 1 is 3. 3 times 8 is 24. So that's 243. Hands if you got that by yourself, some of y'all. Okay? Send me your notes, please. All right. Here goes another one. Do this one by yourself. Example 1, Super Q. It reads log 6 given 12 plus log 6 given 18. Once you're done, send me your problem, see how you did. And go. 6. All right, so we're done with product property. Now, the word product means multiplication. Have we been multiplying when they're adding logs? Yes. Why do we multiply them? Because it's the property called product. But it only works if the logs have the same what? Same base. All right, so we're done with product. Let's move on to the next one. Copy this on your paper. Quotient property of logs. Quotient property of logs. The word quotient implies division. That's what quotient means, the answer to a division problem. Quotient. And what does it say, Mr. Q? It says that if you have a log or two logs of the same base and they are subtracting, what do we do with the given numbers? We divide the given numbers. Divide the given numbers. If we're subtracting two logs of the same base, what happens to the given numbers? We do what? Division. So, let me illustrate just to make sure you see it as I see it. What do we check first? Do they have the same base? Yes. Are they subtracting? Yes. What do? We write only one log. There it is, of the same base. So what do we do with the given numbers now when it's a subtraction? We actually do division. Division. All right? Copy this, please. Example 2. Log 2 of 8 minus log 2 of 32. Log 2 of 8, log 2, 32. All right, let's do this one together. Here we go. What do we check first, everyone, to make sure they have the same what? Base. Are both of them the same base? Yes. Are they subtracting? Yes. So let's write it as one log. Log 2. All right. Next, what do we do with the given numbers? Here are my given numbers. Tell your neighbor what to do with the given numbers now that we're subtracting. Yeah, divide. 8 divided by 32. 8 divided by 32. All right, we're almost done. What does it say here? Simplify if possible. Log 2. Can we simplify this anymore? Yeah, divide by 8, divide by 8. That gives me 1 over 4. All right, let me send you the screen so you can send me your notes. All right, so we got that one. Let me send you one more. Copy this one, example 2 super Q. Let's label this one 2 super Q. Log 4, 128 minus log 4, 8. This is example 2 super Q. We're just rewriting and simplifying the expression as a single log. All right. Do that by yourself. And I'll send you the screen so you can send me your work as soon as you're done. All right. So here it goes. First thing we check is same base for the logs. Yes. Are they subtracting? Yes. So we write one log. Log 4. And then we take the given numbers, 128 and 8, and we write it as what? A division. So, last step, simplify. Log 4, 128 divided by 8. Let's see if it gives an even number. 1, 8, 4, bring down the 8, 6, 48, 0. So this is 16. Hands if you got that. That is correct. All right. So, from 1 to 5, how comfortable are you with rewriting and simplifying? From 1 to 5. All right, we got it. So, with that said, I'm going to go back to the previous ones, and I'm going to add one more step. Look up, please. I'm going to go back to problem number 1. Y'all ready? I'm going to add, on the side, I'm going to write solve. Solve. So, now that we know how to rewrite it as 1, do we know how to solve it? Yes. We set this equal to y. All right? So once we set it equal to y, do we know how to solve this? Yes, Mr. Q, we did that yesterday. All right. So what is the first step? Write it as an exponential. What is my base? 2 to the what? Y equals 128. Next, we need the same base on both. 2 to the y equals 2 to the something. So how many times 2 multiplied by itself gives me 128? Let's check. 2 times 2 is 4. Times 2, 8. Times 2, 16. Times 2, 32. Times 2, 64. Times 2, 128. How many 2's are there? 1, 2, 3, 4, 5, 6, 7. Therefore, y equals 7. All right, let's go to the next one. Example 1Q. I want you to write next to that, solve. Solve. So what's the first thing we do to solve? We set it equal to y log 3 to 43. Change it to exponential. The base is 3 exponent y to 43. Same base. 3y equals 3 to the what? Question, how many times do I multiply the 3 times itself to give me 43? Let's try it. 3 times 3 is 9. Times 3 is 27. Times 3, that's 21, I got 2. 6, 81. Times 3, 3 times 1 is 3. 3 times 8 is 24. There it is. So how many times is that? 1, 2, 3, 4, 5. 5. Therefore, answer y equals 5. From 1 to 5, we'll come to argue with now solving after we rewrite. Yeah, 5, 5, 5. Yeah, we did this practice last night. All right, let's go to the next one. Example 2. Let's go to this one. I want you to write next to that, solve. All right? Do that one by yourself. And Gio's going to guide us through this. And what do I do first, Gio? Y equals log 2 to the 1/4. What do I do next? Change it to exponential. So what do I write? 2 to the y equals 1/4. Now we need the same base. So 2 to the what gives me 4? 2. But it still doesn't look like it. That means I need to bring it up over here. So 2 to the y equals 2 to the -2. So y equals -2. All right, we'll stop right there. From 1 to 5, I'll come to argue with these. All right, 4, 5, 4, 5. Let's do that tonight. Get some practice in. So 3 things. We're going to rewrite, simplify, and at the end, I want you to solve them, please. Those of you following on YouTube, make sure you get some practice in. See you guys next time. Peace.